Welcome to Master Math. Here's a couple of tips to help you get the most out of these lessons. First of all, they're free, so you can watch it as many times as you need to understand the concept. Secondly, if I cover something and it's confusing to you still, hit your back button and look at it again. And third, when we come to a you try it problem, hit your pause key, try the problem on paper and pencil, and then hit your forward key to move on to the answer. I hope you enjoy yourself. Today we're going to talk about angles of polygons, and this is going to be a review for most of you. We all know that a polygon is a closed plane figure made up of three or more line segments that intersect only at their endpoints. Well, you know what a polygon is. It's a shape. It's a two-dimensional shape. There's a couple of words in here that you may not know what it means, though. First of all, closed. That means that there is no openings in the polygon. There's not like a door or an entryway where you could get inside the polygon. All the line segments connect, so it's a closed shape. And it also says it's a plane figure. That means it's a two-dimensional figure. It could be put on a plane, not an airplane, but a two-dimensional plane. Now there's two kinds of polygons. We can talk about a convex polygon or a concave polygon. A polygon is convex if every line segment connecting any two vertices lies entirely inside the polygon. And a polygon is concave if at least one line segment connecting any two vertices lies outside the polygon. Now what that means is that if I draw a line between the vertices in a convex polygon, that line's going to be entirely inside the polygon. However, on a concave polygon, there's going to be at least one line I could draw between vertices that was outside the polygon. And the way I remember concave and convex is a cave is like an entryway into the side of a mountain, and concave means there's going to be like an entryway into the shape. Well, I think you remember that a triangle has 180 degrees. Now the triangle that I drew up here is called a regular polygon or a regular triangle, and all that means is that each of the angles is the same number of degrees and each of the sides is the same length. So I got one triangle there, and we know that it contains 180 degrees. What would happen if I pushed another triangle identical to the first one right up against it and changed it from one triangle to one parallelogram? Because when I push these together, I've really got a four-sided figure that's in the shape of a parallelogram. Well, how many degrees are in a parallelogram? Well, maybe you remember that a four-sided figure like a rectangle has 360 degrees, and a parallelogram has 360 degrees. But if you didn't remember that, you could probably figure it out, because each triangle is bringing 180 degrees to the entire new shape. I've got 60 plus 60 plus another 60 plus another 60 plus another 60 plus another 60. So I've got a total of 1, 2, 3, 4, 5, 6 times 60, or 360 degrees. Well, what if I stuck another triangle on there just like the first two? Would you expect to have 3 times 180 degrees? Well, no, it doesn't work out exactly that way, and I'll show you why. We do have 60 degrees there, and 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 also there, but we lose those 360 degrees because that's no longer an angle. There used to be an angle there, an angle there, and an angle there, but when we combined the three shapes, we lost those angles. So, the number of degrees in this shape is controlled by the number of sides on the polygon, and there are 1, 2, 3, 4 sides. It's a four-sided figure still, so there's 360 degrees. Well, how about if you had another figure presented to you and somebody asked you how many degrees are in this figure? Well, hopefully you'd remember that we may be able to break this up into triangles and figure out how many degrees are in it. And I can see 3 triangles there, and each of those triangles comes to a vertex, and it doesn't eliminate an angle, it just combines to make an angle. So I've got 180 plus 180 plus 180, or 540 degrees. Now there's a formula to help you figure out how many degrees are in a polygon. And if we let S equal the sum of the angles and N equal the number of sides, then the sum of the angles equals the number of sides minus 2 times 180 degrees. This figure's got 5 sides. 1, 2, 3, 4, 5. And the formula would be the number of sides, 5 minus 2 times 180. Or 5 minus 2 is 3. 3 times 180 is 540 degrees. Well, how about this figure? It's a little bit weird. It's weird because it's got a lot of sides. It's a strange shape. It's also weird because it's concave. It goes inward at one of the vertices, and also you could draw a line between 2 of the vertices and it would be outside the shape. So does that affect the number of degrees in the shape? Well, let's figure that one out. First of all, we could break it up into triangles, and you'll see that every one of those triangles is contributing to an angle in the final shape. Every vertice of each triangle becomes part of a vertice of the entire new shape. So I've got 5 triangles in there. 1, 2, 3, 4, 5. 5 times 180 degrees is 900 degrees. So we figured out that this weird shape's got 900 degrees in it. But we could do that a different way too. We could say that the sum of the angles equals the number of sides minus 2 times 180 degrees. And we've got 1, 2, 3, 4, 5, 6, 7 sides. So 7 minus 2 is 5, and 5 times 180 degrees is 900 degrees. That concave vertice didn't affect the total number of degrees in the polygon. Now you try this one. Hit the pause button, do the problem, and then hit the forward key to move on to the answer. We could try to draw triangles on this, but I think math's easier. I think the formula makes this a lot easier. The sum of the angles of the polygon equals the number of sides of the polygon minus 2 times 180 degrees. Well, there are 1, 2, 3, 4, 5 sides on this polygon. So we've got 5 as the number of sides. We subtract 2 from it. We get 3. 3 times 180 degrees is 540 degrees. And every 5-sided figure that you see is going to have 540 degrees. Well, this is just a twist on the kind of problems we've been doing so far in this lesson. We're asked to find the number of degrees in one of the angles of this polygon. And this is a 1, 2, 3, 4, 5-sided polygon. That might help you. Remember, a 5-sided polygon is always going to have a certain number of degrees. Well, if you don't remember, we can figure it out. The sum of the degrees in a polygon equals the number of sides minus 2 times 180 degrees. 5 minus 2 is 3, and 3 times 180 is 540 degrees. So we know that all 5 of the vertices angles will total up to 540 degrees. And we know 4 of them. There's one that we don't know. So if we were to subtract the four values that we knew, 95 degrees, 100 degrees, 115 degrees, and 115 degrees, if we subtract all those from 540, we're going to find out how many degrees are left for x, and that's 115 degrees. How many degrees are in this polygon? Yeah, it's a star, but a star is a polygon. It's a closed figure. It's a two-dimensional figure. It's on a plane. And all the sides connect at vertices. So, how do we figure out how many degrees are in this? Well, we use the formula. How many sides are on this polygon? Well, each of the points of the polygons bring in two sides, and there's 1, 2, 3, 4, 5 points, so there's 10 sides on the polygon. So, the sum of the angles equals the number of sides, 10, minus 2, times 180 degrees. Or 8 times 180 degrees, or 1,440 degrees. My goodness, there's a lot of degrees in this polygon. Angles of polygons. I hope you understand this better now. Well, let's go find out how much you understand. Go to mastermath.info and download the worksheet on angles of polygons and test your skill there. And then go back to Mastermath and try the quiz on angles of polygons. I hope you learned a bunch and had a decent time, and I hope I see you again real soon.